everyone, welcome to Chemoholics, your one-stop channel to make chemistry simple, easy and exam ready. So I have started the series on analytical chemistry, which is part A of paper 3rd in Geochemistry examination, and in this series we are taking different types of numerical problems that already came in previous year paper. So in today's video I have taken one more interesting problem from the 2017 paper, and it has 10 marks. So let's see how we are going to solve this problem. So okay, first read the question. Mixture of KMnO4 and K2CrO4 weighing 0.24 gram on being treated with acidic I solution is found to liberate iodine to react with 60 ml of 0.1 normal Na2SO3 S2O3. Find out the percentage of chromium and manganese in the mixture. Oh, it's very interesting question. It is a combination of Redox titration, then stoichiometry. You are also going to use the algebraic equation, and then you are also going to find out the percentage of the metal ion in the solution. So to solve this problem, first let's see how we are going to solve this question. For that, first we need to balance this equation, like because it's a part of redox reaction where KMnO4 is working as the oxidizing agent and oxidizing this iodine into I negative into iodine. So for that, it has basically two mixture. So we are going to separate this equation in two parts. Okay, so first we are going to use the KMnO4. I am removing this K for making it slightly simple, and this KMnO4 is reacting with I negative and liberating iodine. Okay, first I am going to use the reduction half reaction. This MnO4 minus is going to change into Mn, going to change in Mn plus 2. Here you can see the oxidation state of this KMnO4 is 7, and it is going to, after this reaction, it is going to convert into Mn plus 2. So first we need to balance this. First we are going to balance all the elements other than oxygen and hydrogen, which is already balanced in this equation. Then we are going to move forward to balance the oxygen, amount of oxygen, by adding the water molecule to the opposite side of the equation. So here oxygen is there, so we are going to balance it by adding 4H2O molecule. Then we need to balance this extra hydrogen by adding proton on the opposite side, because this is the method to balance the equation in acidic medium. Basic, if medium is basic, then there is slightly different steps that is used, that we are going to discuss in our upcoming videos or in some other video. So here manganese is balanced, hydrogen is balanced, oxygen is balanced, but that's not the full balance equation. Still we need to balance the electrons in this equation. So how we are going to balance it? Here you can see there -1 charge plus 8 charge is going to give you +7 charge in this side and +2 charge on this other side. So to do that, to balance it, to make it +2, we need to add electron, because redox reaction generally involves the electrons, right? So if we add 5 electron, if I am going to add 5 electron means 5 negative. So +7 minus 5 is going to give you +2. So in this way, on both the side the charges are stable. So we are going to add 5 electrons here. So this is how you need to balance this redox half reaction. Okay, now next, in the same reaction, this I negative is changing into what? I right? We need to balance it, elements, we have balanced it. Now it has -2 charge and here it is 0. So to make it -2, we need to add 2 electrons on the side. Okay, now we are going to add this both the equation, one this oxidation half reaction and the reduction half reaction, but we need to add in this in such a way that these electrons are going to be cancelled out at the end. But right now this is not the case. Here 5 electron is there, here 2 electron is there. So to make it balance, I am going to multiply this equation by 2 and this equation by 5. So when I do this, what will happen? It will become 2, it will become 16, it will become 10, 2, 8, right? Or then when I am multiplying it by 10, 5 and 10. Okay, now electrons are balanced, they are going to be cancelled out. You can add this equation, 2MnO4 minus plus 16H positive plus 10I negative is going to give you 2Mn plus 2 plus 8H2O plus 5I2. Okay, so why I did this? I did this because we need to go to indirect method. They have shown that how much iodine is liberated with the help of this. So I need to balance this equation so that I can found when they react in acidic medium how much KMnO4 is required to liberate this iodine. Okay, so similarly we need to find out this balance equation for K2CrO4 as well, K2CrO4 as well. K2CrO4. Okay, so again I am going to write as reduction half reaction. Here CrO4 minus 2. Here plus 6 oxidation is there, and generally chromium converts into +3 oxidation state. Okay, elements are balanced. We just need to balance water by adding water, 4 oxygen, then by adding proton, 8H positive, and then we need to find out the electron involvement. So here this is -2 plus 8 is gonna be +6, and here it is +3. So to make it balance, we need to add 3 electrons here. Okay, so this reduction half reaction is balanced, and in similar way we need to balance this oxidation half reaction, and this is, we already balanced it, right? It will give you it will give you I2 plus 2 electron. Again when we are going to add this, we need to cancel this out, but right now this is not the case. So for that I am going to multiply it by 2 and multiply it by 3. So when I do that, it will become 2, it will become 16, it will become 6, 2 and 8. Okay, and it will become 6, 3 and 6. Okay, now you can add this. This is going to be cancelled. So 2CrO4 minus 2 plus 16H positive plus 6I negative will give you 2Cr plus 3 plus 8H2O plus 3I2. Okay, so from here we find out that which element is involved, means how much iodine is evaluating, liberating from this KMnO4, and how much iodine is liberating from this K2CrO4. Okay, but still we don't know how much iodine is liberated. Indirectly what they have given that this iodine is further reacting with this Na2H2O3. Okay, now let's see how this reaction is taking place. So N2 plus Na2S2O3. It will give you 2NaI plus Na2S4O6. Okay, this is how this reaction is taking place, where iodine is again converting into I negative ion. Now still we need to find out that how much iodine is liberating. Obviously, whatever amount of this element, this solution is used, that amount of iodine is liberated during the above two reaction. So how we are going to find it out? Here you can see that normality is given, right? So what is the formula for this normality? It is gram equivalent weight divided by volume in ml multiplied by 1000, right? And if you solve this further, you need to find out this gram equivalent weight, right? And gram equivalent weight is, normality is already given 0.1, volume is already given, which is 60 ml, and divided by this 1000. So it will give you 0.006 gram equivalent weight, right? Now what is this gram equivalent weight? Gram equivalent weight is equals to weight of solute, okay, divided by equivalent weight, or we can also write it as weight of solute divided by molar mass multiplied by N. N is what? Here N is, because in redox reaction N is number of electron or proton involved. Okay, this is the meaning. So from here, from using this, we need to find out this amount, weight of solute, because this weight of, from this weight of solute, if we are able to find out that how much this is used, we can also calculate that how much iodine is there. And once we find this out, that how much iodine is there, we can also calculate the amount of KMnO4 and K2CrO2 within the reaction. So how we are going to find this out in this question? So for that, you need to understand what is the structure of these two molecules, right? Especially this. So here the structure is, for this the structure is like this: S double bond O, O negative, S negative. Okay. And here for this the structure is, S double bond O, S double bond O, O negative. So this is the structure. Here you can see that this is, especially this is -2, this is -2, -1, -1. Here -2, -2, it becomes 0, 0, -2 and -2. So basically, as you can see on this sulfur, this -1 charge is converting into 0. And so the N value of N here is what? 1. Okay. Now we will we can calculate this weight of solute. How we are going to calculate it? So the weight of solute is equals to, because we already have gram equivalent weight, right? See, if we are going to change here, we need gram equivalent weight multiplied by molar mass divided by N, multiplied by molar mass, the molar mass of this Na2S2O3. its molar mass is 158.11 divided by n, which is 1, and if you solve this you will find it out as 0.949 gram. Okay, so from here we were able to find out that how much solute is used to react with iodine. Now with the help of this we can also calculate the amount of iodine. So look here, if you balance it you will find out that this is 2. So 2 moles of this is reacting with 1 moles of iodine. Okay, so from here we are able to 158, so 2 moles of Na2S2O3 is reacting with 1 mole of I2, right? Or we can also, because we have in grams, we can change this into mass. So if you multiply 2 moles means 1 mole means 158, then 2 mole means 316.22 gram of this is going to react with 254 gram of iodine. Then how much gram of iodine is reacting with this gram of Na2S2O3? So for that 0.949 gram of this going to react with this as 254 divided by 16.22 multiplied by 0.949, and if you solve this you will find it out as 0.76 gram. Okay, so this 0.76 gram is what? This is the amount of iodine that is liberated when this complete reaction is taking place. This both reaction are taking place. So now by using this reaction we are going to find out how much KMnO4 and K2CrO2O7 is there in the reaction medium. Okay, now let's see how we are going to solve this problem. So first see, for that, because this 76 gram is the part of both of the reaction, right? It's a part of both of reaction, because it is generating from this reaction as well as this reaction. So how we are going to write it as like if KMnO4 is there, okay, KMnO4, see in this reaction 2 KMnO4 is giving 2 moles of KMnO4 is giving 5 mole of I2. Okay, it's 2 mole. 2 mole of KMnO4 is giving 5 mole of iodine, right? Now we don't know, in equation we don't know that what is there, so we can write it as x gram of KMnO4 is there and y gram of this is there, and when we add it, it is going to give you 24 gram, right? So x gram, so when and the mass of this is again 158.034 something. This is the mass of this KMnO4. So 2 mole means multiplied by 2, so 316 gram of KMnO4 is giving, and it's 254 multiplied by 5. If you do this you will find it out 1270 gram of iodine. Then x gram will give, because here we have taken it as x gram will give 1270 divided by 316 multiplied by x. Okay, similarly from K2CrO4, it's y, we have taken it as y. So here in this reaction again 2 mole of K2CrO4 is giving 3 moles of I2. 2 moles of K2CrO4 is giving 3 moles of iodine. Okay, and its mass is 194. 194 multiplied by 2 is going to be 388. 388 gram is giving, and if you multiply it by 254 multiplied by 3, it's going to give you 762 gram of iodine. Then Y gram will give 762 divided by 388 Y gram. Okay, so from here we can calculate the amount of we can find another equation, the algebraic form. One form we have already given, right? X plus y is equals to 0.24 gram, and from here if you divide it it's gonna to give you 4.019x plus 1.964. I'm taking here y is equals to 0.24 minus x. So 0.24 minus x is equals to how much amount of total iodine we have, because this is going to give you iodine, this amount of iodine, this is give you this gram of iodine, and we already know that we have 0.76 gram of iodine, so it is going to give you 0.76 gram of iodine. Okay, and when you solve it you will find it out. If you found 4.019x plus 1.96 this is 4 1.964x, this is minus plus 0.47 is equals to 0.76 gram. You can remove it here. Then you can also find out 2.055x is equals to 0.76 minus 0.47, and it will give you, and if you solve this problem the x is gonna be 0.142 gram. Okay, and if you put it here y will be giving you 0.0975 gram. So if you add it you will find it 0.24 gram, right? So from this we have known that how much KMnO4 is there and how much K2CrO4 is there in the solution, but that is not the question. What is the question here? The question here is we need to calculate the percentage of chromium and manganese. So how we are going to find out the percentage? So percentage of Mn, we need to find it out. Okay, let's see. KMnO4, so mass of KMnO is 158 gram KMnO4 have 54.94 gram of Mn. Then how much is there? We have 1.142. Okay, we need to calculate that how much is there in 142 gram. Here it is going to be 154.94 divided by 158 multiply by 0.142, and it is almost gonna be give you around 0.049 gram of Mn. Okay, then similarly we can now we need to calculate the percentage. So for percentage 0.049 divided by 0.24 multiply by 100, it is gonna give you around 20%. Okay, Similarly, we can calculate the percentage of chromium. So 194 gram of chromium K2CrO4 will have 52 gram of chromium. Okay, then this 0.0975 gram of K2CrO4 have 52 divided by 194 multiplied by 0.0975 gram of chromium, and if you solve this you will find it out around 0.026 around gram. Okay, and if you calculate the percentage from here, 0.0264 divided by 194 multiplied by 100, and it will give you 11%. So this is the final answer of this question. I hope you were able to understand this question. It has this question come up with a multiple concept. If you see, from balancing the redox reaction, then knowing this equivalent weight, how to calculate equivalent weight, then from using this you need to calculate the amount of iodine, then this algebraic form, then this percentage. So it's a mixture of many concepts. Hope you like it and hope you are able to understand this question. And with this I will stop this video here, and thank you so much for watching. And if you like and enjoy this video, please do not forget to like, and please comment what you want to learn from me. And if you are new to this channel, please subscribe this channel and also share this video with your friends. And finally, thank you so much for watching this, and see you. Bye bye. See you in my next video.